Welcome everyone, I'm Michael Uschmann, or known as Mas. I wear a fez, do crazy stuff with Splunk, and I'm from Middle Earth. So, I have to show that, skip. One of my hobbies when I'm not Splunking is photography, and I do pictures like this one, that's Wellington. That was done at the Trust Summit last April. April last year. But the kind of photography I like the most is something like this. That's actually taken from my backyard. I'm not talking about trailing shootings or tracking shootings. It's single shots, unedited. So that's raw. Okay, and I had the idea for this app in 2015, and the whole story or the idea for the app has actually a really fun story behind it. And the best one to tell the story is my friend John Barnett, who used to work at GKC back then, and we had a PS gig in Phoenix. Okay, John, tell the story.
So, hold on.
And we have some extra whales.
I can just shout. Everybody's awake. I can just shout.
Welcome to Thursday.
Let's take this one.
I can use this one. That's fine. I've only got a short bit. So, as Michael said, I used to work with him at a partner. We were both doing PS gigs. Michael started about 6 weeks. Michael started about 6 weeks before we went to Phoenix. I hadn't met Michael before. I'd spoken to him on Slack. We're kind of staying in the same hotel. We had a hire car, and he said to me, we're going to go out for a trip in one night. So I was okay. So I hopped in the car. He put some stuff in the boot. Well, I didn't see what it was. We started driving and further out into the desert. I'm kind of getting a bit worried. I was expecting something maybe like this is what I was kind of expecting. But then we got to this end of this road in the middle of nowhere. He undoes the boot and out come the cameras and stuff. So I was a bit more relieved than that. There you go.
So that night was fun, but the photos were shit because I didn't know how to do it actually. So in this talk, you will learn what questions I asked myself and what challenges to overcome to make something like dark sky photography work in Splunk. Okay, what will you learn in this talk? What is photography in the first place? Some basics about dark sky photography, how and where to get the data, because you need data for that. How to use Splunk as a simple web server or map tile server. How to create map tiles. How to use image data in Splunk, and what the F are you talking about? How not to use KV Store. T-stats to the rescue. Putting it all together, and last but not least, size does matter. I will get there. Okay, so the first thing is, what is photography in the first place? Any ideas? Physics. You have weather, moving Earth, moving stars, so you need to know about the physics. Then we have math. Not Splunk math, but simple math. Chemistry. Could be old school 35mm films that you need to develop, or endorphins that you get when you shoot something like this. That's one of my best shots so far. That was also like a 2-minute walk from the place where I live, down at the beach. Okay, so some basic dark sky photography rules. We have the 500 rules. That is, you take 500 seconds divided by the focal length of your lens, and you get a safe number of seconds you can shoot. So if you have like Let's take a 50mm lens, so you can shoot for 10 seconds without getting blurry stars or trails. Then the bottle light scale. That's actually a scale that quantifies the astronomical observability of celestial objects. I had to Google that because I didn't know about celestial objects and stuff like that. Everything is based on Google Science. So I'm no astrophysics, whatever. I'm not a pro in photography. It's all just Google Science. Yeah, and the bottle scale ranges from 9 to 1. So 9 is shit, 1 is awesome. So you need to know about that. Okay. And fun question about light pollution. Because light pollution is not only human-made, we also have natural light pollution. And any guess about where is the worst place for natural light pollution? Any ideas? Yeah, so don't try it in Antarctica. Yeah. Which one is none? Yeah, okay. You also should know the lunar phases. So, of course, you don't want to go full moon because it just illuminates the sky. So, no sense to go with full moon. You want to go either week before or after new moon. That's perfect. The next thing, you need to find the Galactic Center or the core of the galaxy, because that's this huge bright spot here. So that's the easiest objects to start with. This one. Yeah. And for this kind, or for this task, there are plenty of iDevice apps around that will show you exactly when and where the core of the galaxy is, but they don't show you weather data, they don't give you other information, no light pollution, nothing. So, where did I get that from? And another hint, the Galactic Center is visible in the southern hemisphere from February to October, in the northern hemisphere from March to October, so during summer, which is, yeah, sorry guys. And don't try to look for it during November until February anywhere, because it's simply not visible. Okay, so how and where to get the data from? The first thing is the NASA dark marble image. It's, for me, the only known source of light pollution of the Earth. There might be something else, but it's not public. And the funny thing about this image is that since Earth is 3D, they had to make a, how is it called? Orthographic projection, which converts 3D into 2D. So think about it. Think about it. NASA provides a flat Earth. Yeah. Okay, NASA also provides a Moon API, which I just found out this morning doesn't work anymore, so we will not have Moon data, sadly. A weather API to get weather condition, because you want to have a clear sky, dry air, less wind as possible, because wind actually moves the camera around. So, and Mapbox direction API to find out where we actually have to go or how to get there. And everything is made with a custom Splunk command, which is called getMe. Haha. So various options that you can tell the command, get me directions, get me weather, get me moon, whatever. And it has this Easter egg. Okay, so now we have the data source for the light pollution, but now what? Okay, so we can use Splunk as a web server, because JerryPy is just a web server if you look at it. Or we can also point it to different, oh sorry, blah, blah. I got lost. Okay, we can point Splunk to web tile server URLs, or just use Splunk itself as a web server, because CherryPy is just a web server. So if you put something into ITSI apps, foobar, app server static, you can call that directly in the Splunk UI. Okay, so now we know we can use Splunk as its own map tile server, but how do I create map tiles out of an image? So we have the data in, or we have the dark sky, the dark marble image from NASA, but it does not contain any geolocation information. So we need to ingest that first into the image to be able to use map tile producing tools. So I used a GDAL library to ingest geolocation information into the image. And then I used tilemap to create 9 gigs of map tiles, which I then can use in Splunk as a map. And the 9 gigs is the reason why it's not on Splunk base. It's hosted on GitHub, and the map tiles are in mega.com. Simply too big. So that's how it looks in the end in Splunk. Okay, so, but I don't want just use the image as map tiles. I want to use the data because we have data there. But how do I get it? So, what the WRF are you talking about? So I'm not talking about XF information. I want the real data out of the image. And since I know it's a 2D image of a 3D object, and I ingested geolocation information. Think about it. All of a sudden we have structured data in an image. Each pixel represents a geolocation, and we can get each pixel's brightness using R. So that's the structured data, and R has a fancy feature to get out of a raster image, which we now have, a CSV file. So that's the command that I used. Runs pretty quick on the laptop, and the result is, a 90 million line CSV file. So a lot of data. My first approach was to use KV-Store. I hope that works. And yeah, KV-Store simply exploded by trying to load 90 million lines of a CSV. And we all know, come on. Got you all. Okay, yeah. KV-Store is MongoDB web scale. We all know the problem, so forget about it. So the then solution was to use accelerated data model with all the index data, and simply use tstats on the data model. So that's the base search, which feeds the whole dashboard. Okay, and now putting it all together, so I have used the dark marble TIFF as map tile source, and yeah, light pollution source, the weather and moon API to get the current conditions. That's the actual data out of the image, shown as a heat map overlay. And that's the direction from the Mapbox API. So, and now I said, size does matter. It does, from a photography point of view. Because if you look at the different sizes of the sensor of your camera, the bigger the sensor is, the more light you get on it. It's simple as that. So lots of the cameras have APS-C sensors, which are really small, and you would need to get a longer shot time to get the same amount of light as a full frame camera, or even a medium format. So the bigger the sensor, the shorter the shutter time can be, the sharper the image as an end result. So that's why size does matter. So I'm shooting with a full frame. I tried it with APS-C, it doesn't work. We had someone try to do it with a smartphone. No, because the little frame back there is a large smartphone sensor. So usually they are under 1 inch. Okay, demo time. So the whole app is made out of 2 dashboards. The first one is the location. If that thing would run on a public web server, it will pick out automatically your IP address and resolves it and would show it. But it runs on my laptop, so I just had to use filters to get everything. And once you click here, you get to the next dashboard, which uses then all the information from the various APIs, from the accelerated data model, shows it in real light pollution from 0 to 255, and as a Bortle scale. Then you get the distance to the closest, darkest place, the direction, and it also tells you in which direction you should take your photo and in which not. It doesn't mean that the Milky Way will be there, but at least it's dark there. And that's the wrong one. Yeah, that's how to get there. Just some fun details about most light pollution and least light pollution. Down here I added a little calculator for the 500 rule, where you can see, okay, if I have a Canon with the APS-C sensor at only 10 seconds, full frame 17 seconds, medium format 33 seconds, yeah, and Nikon is 11 seconds. And the Easter egg in the Get Me app is random beer facts. So if you call it Get Me Beer, you get random beer facts. That's it. Any questions?